Hello everyone, I am Professor Pavan Makhija from Acropolis Institute of Technology and Research. Today we are going to discuss about the topic Introduction to Data Science that is coming under the part of machine learning. So what is data science? Data science is solving problems with data. We have a number of data that is available in today's life that may be scientific, social or related to business problem. Based on this, we are going to select the data problem. After selecting the data problem, we are going to collect and understand what kind of data is required in order to solve that problem. Once we have the data with us, we will first do the EDA process. That is normally we call it as exploratory data analysis. We'll clean and format the data so that the data that is available to us will be used in order to create some sort of solutions. Isn't it? It sounds cool to you. So if I'll ask what makes a good data scientist, the answer would be one who will be proficient with mathematics, statistics, and domain expertise is required. So if I'll ask that out of these five steps, which step is most challenging? Either data analysis or machine learning or both. We have to understand one by one each and everything. So let's discuss what is data analysis. As I already told you that using data, we need to discover some useful information. It is somewhat data analysis is about. So what is data? Anything you can measure or record, unstructured, structured, these are the kinds of data that we are coming across our daily day-to-day life. Statistics, we need to summarize, we need to visualize. This is the main characteristic of the data. And the algorithms, that is the fury or essence of any data analysis platform, where we need to apply algorithms to find different patterns in the data, which will help us in identifying the solution. The next thing would be machine learning. Now, machine learning is somewhat related to data analysis or data science, where creating and using models is the USP that will learn from the data, and data is nothing but unstructured, structured, or any kind of data. That means if I talk about artificial intelligence, so we'll say that making machines just like human behaves, or replacing men with machine is artificial intelligence. In order to replace that machine by men or by men with machine, we need some sort of algorithm that is typically coming under the hood of machine learning. What would be the model? The specification of a relationship between different variables. This will be one of the models that is the part of machine learning. And how will you evaluate that your model is performing well? It depends on the number of parameters, that how does well it's suited, or how does this model works, right? So typically we have a pictorial representation of machine learning. We have traditional CS and machine learning. In the traditional computer science theory, we'll be dealing with data as well as the program that needs to be fed into the system, and we'll be getting the output. Whereas the beauty of machine learning is we have the data, also we have the output. We'll feed these data and output to the machine. It will again be fed into the data and the program that was made by the data and output, which will again give us the output. That is simply we are talking about machine learning. So what is machine learning for you? Creating and using models that learn from data. These are some examples: that identifying zip code from handwritten digits, detecting communities in social networks, or you can say in the traffic rush hours, you need to predict the traffic volume at rush hours. Let's say you want to travel from X position to Y, so you need to understand that how much estimated amount of time needs to be given in order to reach from one place to two. Here, machine learning is going to prove very helpful for you. Detecting frauds related to credit cards and other financial banking transactions. Machine learning is also working and proving very helpful to the society, determining the location of distribution centers based on the customer's residence. Then we have some sort of machine learning algorithms that are required in order to prove that why machines are better than men. So the foremost or the first algorithm of machine learning is regression. So how many of you are aware about regression? Regression is nothing but just to fit the features to a standard that will try to minimize the errors. This is what regression is all about. Here I have drawn something that I have some sort of data related to a house price prediction. So I have already some features available in that data set. The data set might consist of the number of rooms of that house, the square feet or the size of the house in terms of square feet, or other amenities that may be the part of that data. So I have depicted this with this dollar, dollar, dollar. These are these features that I've written: square feet, number of bedroom, XYZ. So there are kinds of algorithms related to regression. We'll talk about linear regression, where the main idea behind regression or linear regression is to map the independent variable with dependent variable. Here, if I say that I need to predict the price of the house, so the independent value will be the size of the house, the number of bedrooms, the locality, XYZ. Based on these independent features, I need to predict the price of the house. That is y is equal to mx plus c. That is the line of equation. Basically, it is coming under the hood of supervised learning. I can predict the price of a house by training my model with the help of a model that is known as linear regression, which will help us in order to fit a straight line. This straight line will fit in such a way so that the difference between the actual values and the predicted values should be minimum. This difference can be calculated on the basis of, I must say, Euclidean distance or any other kind of distance that you can go for, right? So in this way, regression. One more very popular algorithm that normally we used to come across while coming for data science or machine learning: classification. The difference between classification and regression is continuous values. Here we have continuous values and we need to find the price of the house. When we have continuous data, we need to solve this using regression. When we have some sort of discrete values, in that case, we need to solve this kind of problem that is typically known as classification problem, where we have some sort of data. Let's say we have a fruit class, or in this example, what I've done is I have done reviews, movie reviews. Reviews may be positive or negative. Based on the review, I can classify that this review could be a positive review or be a negative review, right? So I'll make sure if the score of that particular review is greater than 5. So that may be considered as a positive review. And if it is less than 5, then it is a bad review. So our algorithm is helping out in prediction of these reviews, whether it belongs to a positive review or it belongs to a negative review, right? This is also using supervised learning algorithms. Then we can also learn from the data, because we are totally inclined towards the data. Clustering, that is a kind of unsupervised learning, whereas we are not trying to classify different classes. Instead of classifying in different classes, we will be dealing with unlabeled data, and with the help of this unlabeled data, we are going to identify the structure. We are going to create the clusters set based on the properties this new attributes or this new article is going to cover in which cluster. It belongs to cluster 1, cluster 2, or cluster 3, right? So we are going to grip similar article in one cluster and other kinds of article in different clusters, right? So this is a rough introduction about this. Then again, talking about what is machine learning. So we must say that creating and using models that can learn from data. We have gone through regression, classification, and clustering. I'll definitely teach you, I'll definitely deliver the content related to each and every algorithm in detail in the next lecture, right? There are two kinds of learning we have studied. One is supervised learning, second is unsupervised learning, right? So when we talk about supervised learning, we'll come up with predictions. When we talk about unsupervised learning, somehow we are going to find out some of the insights or trying to extract knowledge that is much more related to data mining as compared to supervised learning where our focus is on predictive modeling. So this is one of the activity that we have already gone through. We are going to summarize this, categorizing these examples, right, based on regression, classification, and clustering. Machine learning workflow. Basically, machine learning workflow divides into three tasks: training phase, test phase, and evaluation phase, right? So first we have the data and output. We'll fed this to the machine. This machine will create a model. This model, because this model is going to train himself on the data that is provided by us. Now, from a new perspective or any unseen data will be fed to the machine with our model that was trained on the data. It is going to give the output, and this output is going to be compared with the ground truth, that is the base or benchmark, and based on this ground truth we will compare the performance, that how much accurate or how much precise our result or output as compared to the ground. This is another example, census data, where you can go for census data. We have data denotations, all observed data. X and Y are the features and observations. These are some denotations or notations that we are going to cover in our next lectures. Typically, what data structure we need to use in order to solve a machine learning problem? Basically, we'll deal with some of the Python kind of data structures that have set, list, or array. You need to figure out, this is an assignment for you. And this is a summary that today what we have covered, right? Thank you so much for your time.